Okay, morning, boys and girls. It's me again, your math teacher, Daniel. In today's lesson, or in the second lesson, we're going to learn the multiplication of factors. So, you might want to ask, what is a multiplication of a vector? So, let me tell you, by the end of this class, you're going to learn how to multiply a vector by a scalar and describe the resulting vector's magnitude and direction. So basically today's lesson we're going to learn how to multiply a vector by a scalar. And then we're going to learn how to represent scalar multiplication both algebraically and geometrically. And also you're going to know how to define univectors. And the definition of univectors will be very, very important in the class later. So, first of all, we need to get into the concept of scalar and vector. So, as we know, vector is made of direction and magnitude. So, for example, if we say vector A, then we have to label its direction, and also we have to know its magnitude. And also, but on the other hand, if we want to know scalar, we only need to know its magnitude, because scalar doesn't have a direction. So the multiplication of vector by a scalar doesn't involve the calculation of two vectors. It's very simple, and it only involves a number and a vector. So multiplying by different values of k can affect the direction and the magnitude of a vector. So depending on the values of k that we use, what is that sentence means, or what is that briefing means? As we can see here, so the k are different, and they have a different magnitude, and then different values. So for example, we have a given vector a, and then if we multiply this vector a by a scalar k, which is bigger than 0 and smaller than 1, so we can see k as some fraction like 2 over 3 or 1 over 2. So basically the a is shrinked, and then the k vector a is smaller than vector a. Then let's move on to a k that is bigger than 1. So it can be 2, it can be 3, it can be 4 over 3. So as long as it's bigger than 1, then if we multiply the vector a by the k, we can get a completely new vector which is bigger than a, the vector a that was given. So you can tell by the length, and it's very, very directly seen. I mean, you can see it geometrically, and then we can see if the k is bigger than -1 and smaller than 0. So if k is smaller than 0, or we can say it's negative, if we multiply vector a with a negative scalar, then the direction of the vector a should be changed, or alternatively it should be changed to the opposite direction, so we can get k multiply vector a. And if the k is bigger than -1, smaller than 0, which can be like -1 over 2, so it is shrinked and also in opposite direction. And if the k is smaller than -1, like -2, -3, -100, then the k is the k uh, the k multiplies factor a will get a longer or a bigger version, or we can say it is bigger, or and the direction is also pointing at the opposite. So that's how we uh, that's how we multiply the vectors using k, and it will it will differ when it comes to different values of k. Also, we have to consider if the k is bigger than 0, or or smaller than 0, if it's between 0 to 1, or between -1 to 0. So let's move on. And then the scalar multiple results in parallel and collinear vectors. So what does that mean? Which means a scalar multiple doesn't change the whole thing. It can be parallel, or they can be collinear. They won't be perpendicular after the scalar multiple. So the next topic, let's move on to the unit vectors. So a unit vectors have a definition of unit vector is a vector whose magnitude is 1. So it's very simple. Like the vector a, if we say the a vector a is a unit vector, then it has a magnitude of 1. And if it's a force, then it has a unit of Newton. So it's 1 Newton as a unit vector in force. So the vector b has a magnitude of 1, which makes it a unit vector, or we can say unit vector b has a magnitude of 1, and the unit of it is meter. So 1 meter equals it means that it is a unit vector in length. So let's have a further research. How can we get a unit vector? So for example, if the vector a is not a unit vector, let's say it can be anything, any vector except a unit vector. So the magnitude of a is not equals to 1. So if we want to get the unit vector, we need the direction of the vector a, and we need to make the magnitude of that of the vector equals to 1. So we need to make the magnitude of vector a 1 over the magnitude of a times vector a, so that we can get the direction of vector a, and also we made the magnitude of vector a 1. So that's how we get a unit vector. And then if it is positive, then it is parallel and has the same direction as vector a. And if we made it negative, which is -1 over magnitude of a, then we can get the parallel unit vector, but has an opposite direction with vector a. So let's make a quick summary. So unit vector means the magnitude of vector is equal to 1, and a multiplication of a vector by a scalar will change its direction, that can make it parallel, or it can make it parallel but opposite direction. So scalar multiple results in parallel or collinear vectors. And thank you. Class is over.